Welcome, everybody. Thanks for taking the time to join today's webinar on ransomware protection and recovery in AWS. We have a packed agenda. I'm Chandra Reddy, and we'll give you an overview on ransomware, followed by 10 strategies for ransomware protection and recovery. My colleague Ramesh will share and demo a self-service assessment tool that your team can use in your environment right after this call or sometime this week. Nicholas will then dive deep into two of the most important tools, Amazon GuardDuty and Security Hub for ransomware protection. And Alan Henderson will share how to recover your data after a ransomware incident from backups. And while I'm going through the presentation, please do not hesitate to ask your questions. Put them in the chat window, and our friends here will be happy to respond back in live. And we will also have 10 minutes, I think, of Q&A time towards the end, where we can have a live discussion as well. So with that, let's get started. So cybersecurity, especially ransomware, has been a big challenge across the globe. The problem is particularly more severe in on-premises environments. Gartner predicts that 75% of CEOs will be personally liable for cyber physical security incidents by 2024. That's telling. Even President Biden issued an executive order that's more than 8,000 words long on this topic. So without further ado, let's first dive into how ransomware attacks and how it spreads in an environment. So in most situations, it all begins with an innocent click on an attachment in email or a website that downloads malware on your laptop. The malware then tries to move laterally to other servers in the network. It looks for unpatched systems or cached or leaked passwords and gets into more critical systems. And at some point, it applies ransomware encryption lock on the data. When you access the data, it throws up a ransom note. Sometimes it even locks the backups so you cannot restore from those backups. The impact of ransomware attacks is massive. Most pay ransom, many pay government fines, they lose trust and brand value, some even lose their jobs, and the worst part is when healthcare system goes down, it could even lead to loss of life. So how do we defend our digital assets? What are the various strategies? And that's what we'll talk in the next few minutes. NIST is a great framework. I will share a white paper and a slide in the appendix section today that maps all the AWS tools to this framework to help improve your security posture. Today, in this session, I will focus more on the strategies. Now, there are many strategies for ransomware protection and recovery. In the interest of time today, I'm going to focus on the top 10 that I think will be very helpful for you all. So number one is start with the laptops and desktops. Protect the laptops and desktops using products from, there are many vendors out there like CrowdStrike, SentinelOne, Tenable, Trend Micro, just to name a few, so that malware can be detected and stopped right there. But we will take a zero trust approach. We will assume a new variant will come that will go undetected on the laptop. We will also assume that botnets will attack unpatched servers in your environment with vulnerabilities and find a way into your network. The malware will then try to attack vulnerabilities in other servers. If organizations can keep up and keep their systems patched, ransomware will not be able to target those servers. Thus, you need tools that can identify which servers have security vulnerabilities, and then you need a tool to patch those servers. But according to NIST's National Vulnerability Database, approximately 50 patches are released every day. It takes time to test patches and then deploy them to production. Many organizations fall behind. So automated testing and patching will definitely help alleviate the situation. AWS Systems Manager, Patch Manager can help with all these requirements. But instead of patching production servers, what if we use immutable instances that are very short-lived? So let me explain. Instead of patching production servers, let's assume we test and patch an AMI template, and then use these templates to launch immutable instances. Thus, you get out of the business of patching production instances totally. Also, what if the life of the immutable instance is just a few hours? So we terminate old instances and spin up new instances from the template for high availability. All of this automated, of course. Another strategy to get out of the business of patching servers is to consider storing data in a fully managed data store in AWS. Here are a few examples of such managed databases. So you don't have to manage and patch databases in EC2 instances. And here are some file storage services. So you don't have to manage and patch file servers in EC2 instances. And these are for big data analytics. For all these managed data stores, AWS takes care of patching. Thus, you don't have the pressure and burden to patch servers with mission-critical data. Thus, you can reduce time to market your new capabilities with better quality for your customers. One of the first things malware does is extract the cached or stolen passwords and use them to gain access to servers and spread ransomware. So we need to set up least privilege policies for users and roles. When you have hundreds or maybe even thousands of users and roles, this gets hard. AWS makes it a little bit easier for you. It uses automated reasoning, learns and analyzes API activity in CloudTrail logs to determine which users and roles need what API permissions for which AWS resources, and more importantly, it automatically creates IAM policies with minimal permissions, minimal but required permissions. Such automated capabilities not only helps improve your security posture, but also reduces your operational burden to get it right. But going back to zero trust, I will also encourage you to think about not giving any user access to production instances. If somebody wants to make changes in production instances, have them get change approvals and use AWS Systems Manager with multi-factor authentication. Basically, we want to keep humans away from production instances and data. Okay, so far we built 5 layers of defense, right? How about we reduce the blast radius further? Consider building fences for your various applications using different AWS account IDs or different VPCs within an AWS account to minimize the blast radius. Now, within a single VPC, you could have servers in public and private subnets. So adopt zero trust attitude. Assume that malware exists in one of these servers. So use security groups to limit communication from and to very specific IP addresses and ports. Enable VPC flow logs. We have tools to analyze these logs to detect anomalous traffic to an IP and or port and raise alerts. By using these techniques, in a worst case scenario, if one of your machines in a VPC does get infected, it won't spread to other servers and thus limits the blast radius. Okay. Now, attackers will try to exploit vulnerabilities in your web applications. So use a web application firewall to avoid such exploits. Attackers could perform brute force attacks. So use AWS Network Firewall to inspect and filter all traffic. This is all basic hygiene, right? Identify unintended access to your EC2 instances from outside your VPC. Amazon Inspector can help you. And when you have hundreds of firewall rules, security groups, and VPCs, you need a single pane of glass to manage everything. So for this, you can use AWS Firewall Manager. It reduces your operational burden, reduces human errors, keeps it simple for you. Okay, so now think of a scenario where you have done all these things, yet there is an instance that gets infected with malware and it attempts to reach out to an external IP, something that it has never done before. So that's an anomaly, right? And that can be detected in near real time. And more importantly, an action can be taken automatically. Amazon GuardDuty helps you with that and many other anomalies in near real time. GuardDuty and Security Hub are the two services that I strongly encourage you to explore further. And actually today, Nicholas will dive deep into these two topics in just a few minutes. Next topic is data protection. Ransomware might try to exfiltrate data. So use mechanisms like S3 access points so that data can be accessed only from within your VPC and not from public internet. Also use encryption at rest. What if ransomware locks your data with encryption? If you have backups, you can recover your data from a previous point in time. Thus, please make sure you're backing up your critical apps. And Alan will cover a little bit more dive deeper on this topic later today. Remember zero trust? What if an internal bad actor deletes your backups? Replicate your backups to an account with a different owner, thus reducing the deletion chances from the second account. Now, not all data is born equal. Some apps need recovery time objective and replication in minutes. For those apps, use AWS Cloud Endure for rapid recoveries. And the last strategy is about hybrid cloud. So many of you have already asked me, how can we help you for your on-premises applications? So here are a few recommendations. Protect your laptops and workloads on-premises from malware and ransomware using products such as CrowdStrike, SentinelOne, Tenable, Trend Micro, Securonix, and there are many others. Evaluate those that look for signatures as well as use machine learning to detect anomalies at scale in near real time. Also, automate patch management at scale using tools like AWS Systems Manager for your on-premises workloads. The second topic here would be that most backup vendors such as Cohesity, Commvault, Veeam, Veritas, and others have deep integration in AWS. So modernize your backups by replicating backups to Amazon S3. And then all these products have integration with a feature in S3 called S3 Object Lock to make the backups immutable in AWS so that an internal bad actor will not be able to delete those backups so that you should be able to do the recoveries. For critical workloads that require rapid recoveries and replication in minutes, consider using AWS Cloud Endure or VMware Cloud DR in AWS. If you have lots and lots of VMware virtual machines and you need to continue to use VMware VMs even after a disaster, you could use VMware Cloud DR. So to summarize, we covered 10 strategies for ransomware protection and recovery. Consider a zero trust approach. As mentioned before, keep humans away from production instances and data. There is no silver bullet. Please add multiple layers of defense as we discussed today. Since social engineering is one of the biggest entry points, educating your users is extremely important. Enforce strong passwords and multi-factor authentication. That's very critical. Ransomware protection is not a one-time activity. Please consider using continuous threat detection that uses machine learning at scale with automated incident response. Perform penetration testing, automate incident responses, test recoveries, automate large-scale recoveries. These steps will raise the barrier against ransomware attacks and keep you out of the news for the wrong reasons. So these are the 10 strategies that I wanted to share today. We'll dive deeper into a few more topics, but one of the best things you could do this week, right after this webinar, is to have an assessment of your security posture. It's easy, it's self-service, and to help you with a free assessment tool and how to use it, I would like to invite my colleague Ramesh, who will demo this tool. Ramesh, take it on.
Thank you, Chandra. So I will start sharing my screen to show the demo. All right. So are you able to see my screen now?
Yes.
Okay, cool. Thank you. So thank you, Chandra. So basically in this presentation, we are going to demonstrate the self-assessment tool, which can help you in assessing your security posture to identify and remediate the security gaps that are susceptible to ransomware. We will be sharing this blog post after this webinar. So this is an inexpensive, easy to deploy, secure and fast solution to provide our customers 2 security assessment reports. These security assessments are from the open source projects Prowler and Scott Suite. Each of these projects conduct an assessment based on AWS best practices and can help quickly identify any potential risk areas in a customer's deployed environment. So one thing to note about this self-service assessment tool is it is a one-time snapshot of your environment. It's not a continuous assessment. So for doing a continuous assessment, we will be sharing the best practices on our next presentation. But what you can do is you can run this one-time self-assessment to see where you stand in your security posture as of today. So Prowler is the security tool to perform AWS security best practice assessments, audits, and incident responses. It contains all the CIS controls and many more additional checks that can help on GDPR, HIPAA, and other security frameworks. So it has around more than 180 checks covering security best practices across all AWS regions and most of AWS services. Scott Suite, the other security tool, is an open source multi-cloud security auditing tool, which enables security posture assessment of cloud environments. So basically, the blog has all the details on how to run this tool. But basically, the first thing is like you will go to the GitHub link that is provided on the blog, and you can see the code section here. You will just download the zip file onto your local desktop machine. And then once you downloaded that zip, you can upload it into a S3 bucket where you can see, as you can see on my end, you will just like upload everything onto your S3 bucket like you see here. And once you upload that, you will just select the self-service sec.yaml file. This is the YAML file that launches all the resources that is needed, and you will copy the S3 URL of that file. So once you copy that S3 URL, we are going to be using CloudFormation. So CloudFormation is basically the AWS service that lets you create infrastructure as code. So I'm going to be creating that CloudFormation stack, and I'll copy paste the URL that I just copied, and then I'll go through the steps here. And for stack name, you can just name your stack anything that you want. So in this scenario, I'm naming it as self-assessment. And then the bucket name is where you copy pasted the files from the previous step. So in my case, my bucket name is named as security ransomware, security posture ransomware. So I'll just name it that way. And then you can go through the next set of steps, and you can leave it at default options here. And then on the final step, you will just acknowledge here, and then you will click on create stack. So the stack creation itself will take around roughly 10 minutes, but I have pre-created the stack before I came to the presentation. So once everything got launched, this is how it would look like. You can see the stack had successfully created, and you can see the list of resources that is created as well. So the list of resources that you see here is additional CloudFormation stacks that are created. So also on the stack creation, we give you an additional ransomware check modules. So basically what that does is it will check for the AWS core security services if they are enabled, such as GuardDuty and Security Hub, which we are going to be talking in the next presentation. And also it will check for data protection checks, such as if the EBS volumes are running with no snapshot, or if you're running on an outdated OS, or if the EC2 instances are not to be managed with SSM. So it will do those additional checks as well. And one more thing that is available is we also have the SolarWind optional module that needs to be run separately. So we will provide the template on the GitHub page. You can just run the SolarWind module as well. But coming back to the created CloudFormation stack, in the output section, you can see the S3 bucket that is created. So this S3 bucket is where all the security reports will be delivered to. So the CloudFormation stack will take around 10 minutes for the launch, and the EC2 instance where the Prowler and Scott Suite reports are going to be running, it will take around 40 minutes for the reports to be delivered into this newly created S3 bucket. And when you go into that newly created S3 bucket, here's all the outputs that you can see. So basically, I enabled the ransomware module as well as part of the CloudFormation stack launch. So it will give you those checks as well, and it will give you the Prowler and Scott Suite output as well. So as to what the output would look like, so for the optional ransomware modules, I'm just going to be showing the snapshot of how that's going to look like. So you can see how it will show you basically if the EBS snapshots are present in the account, and if backups are not enabled, it will do that check as well. And it will check for the security core services like GuardDuty, and if they are integrated with AWS organizations, and also it will check for any outdated OS that we are running. So basically it will give all this output. And coming Scott Suite and Prowler. So the Prowler output will have, like I mentioned, it has more than 180 plus checks. So it will do a complete check of the environment, and it will give you the results in terms of whether something that is critical or high. So you can basically go over the list of security issues that are identified, and there is also the remediations that are listed there. And the Scout report, it's same like Prowler, but it will give you the list as each AWS service. So for example, if I want to focus on a particular AWS service like EC2 to see what is happening with the EC2 service, I can just go there and it can show that EBS volume not encrypted. So I can just expand on it and see how to fix that. So again, like I mentioned, this is like a one-time snapshot to see where you are standing as of today. But if you wanted to do a continuous assessment of your environment, my colleague Nicholas, I will hand it over to my colleague Nicholas, who is going to be covering that next.
Perfect, thanks. When you're operating workloads in AWS, there are some precautionary measures you can take to help detect threats, including ransomware. So the two services I'm going to talk about to help with this are Amazon GuardDuty and AWS Security Hub. You can go ahead and jump to the next slide. So starting with Amazon GuardDuty, GuardDuty is an intelligent threat detection service. It provides you with an accurate and easy way to continuously monitor and protect your AWS accounts, workloads, as well as data stored in Amazon S3 or our simple storage service. Getting started with GuardDuty begins with just a few clicks in the console, very easy to set up. From there, GuardDuty analyzes billions of events across your AWS accounts, including AWS user and API activity in your accounts, network traffic data, and other logs. GuardDuty threat detection identifies activity that can be associated with account compromise, instance compromise, malicious reconnaissance, and bucket compromise, again, in our simple storage service. And GuardDuty delivers more accurate findings using machine learning enriched by threat intelligence. And then finally, you can take action on potential threats by integrating into event management or workflow systems, or by triggering automated response or prevention. Let's take a look at the interface for GuardDuty. You want to jump to the next slide? There we go. Beat me to it. Once you've enabled GuardDuty, this is the main findings screen where you'll see findings listed out by severity. A couple things to note. You don't need to have any logging turned on in an account in order for GuardDuty to process any of the log types. All that logging is done on the back end as GuardDuty gets them directly from relevant resources. So there's no need for architecture changes, no agents, and no account performance impact. And then from this list, we can click into a particular finding to learn more about it and the impacted resource. And here you can see a description of that finding, severity label, and the information about that resource, kind of everything that you need just to get started. Now let's take a little bit of a step back. This is one security service that you might be using. You're also hopefully using IAM Access Analyzer, which was mentioned earlier, to help you automate least privilege. You might also be using Amazon Macie to discover and protect your sensitive data at scale. As you leverage different tools available to you, you'll eventually realize how beneficial it would be to have one comprehensive view of your high priority security alerts and security posture across your AWS accounts. And that's where AWS Security Hub comes into play. You can go ahead and jump to the next slide. So similar to GuardDuty, you can enable AWS Security Hub with a few clicks. Once enabled, Security Hub automatically aggregates security findings in a standardized data format from both AWS services seen here and partner services via integrations. Security Hub can also conduct automated security checks as well as deviations from security best practices with a single-click deployment. Finally, you can accelerate your mean time to resolution with automated responses and remediation actions. You can go ahead and jump to the next slide. So this is an example information flow with AWS Security Hub. Starting from the left, Security Hub receives findings from different AWS services, partner integrations, as well as security checks. It lists out all those findings in a single pane of glass for you. You're able to launch investigations from Security Hub using Amazon Detective, which is bottom center there, and that will analyze and visualize security data to rapidly get to the root cause of potential security issues. And then finally, working our way to the right side of the slide, you can do things with those findings in Security Hub, such as send them on to a third-party service or automate responses and remediation actions. Let's zoom in on the taking actions piece of this. Security Hub findings are automatically sent to CloudWatch events. You can set up CloudWatch event rules to pick up relevant findings and trigger Lambda functions or send them on to various other services. You could enrich those findings with additional data, maybe GeoIP data or other contextual information. And then you can send those findings on to either a partner solution or a solution you've built to take further action. Let's go ahead and jump into the console. I've got a couple screenshots. So jumping in here, I'll walk through a couple elements of the UI. For starters, this view is for multiple accounts. So the layout is the same as for a single account, but in this particular scenario, we're looking at the aggregate view across your organization. So if I was on a security team and I logged into the account that you delegated to be the security admin account, this would be what I would see. And as you can see here, I've enabled 3 security standards. Each of those includes a collection of automatic or automated security checks that look for deviations from security best practices. If you want to see all of the findings for your organization, you can click on the findings link on the left, which brings you to this screen. Again, the findings you see here may come from the automated checks in Security Hub or other AWS services or partner integrations. And this is for all of the accounts in your organization. Similar to GuardDuty console, you can click into a finding to pop out a drawer with more information. There we go. And from here, you can start your investigation and respond. So at this point, we've taken some precautionary measures to detect ransomware using GuardDuty as well as Security Hub. At this point, I'm going to hand it over to my colleague Alan to discuss backup and recovery.
Thank you, Nicholas. I just want to confirm my audio is working. I have unmuted myself.
Yes.
Great, thank you. And Chandra's going to drive the slides. So Alan Henderson, a storage solution architect here at AWS. Let's go to the next slide. So we're going to be talking about how AWS Backup can help you, back up, replicate, and recover your data from the different data services within AWS. As mentioned earlier, it's you could and should prevent this from happening, but in the case that it does, this is how we can help you recover. I'll make one more comment about AWS Backup is that as a service, there's no cost for it, but it will consume storage, and that is what the charge is for, and those are listed out in the various different services as the backup storage costs for the different services. Next slide there, Chandra. So I took an example that is actually documented inside of one of our documents here. The link is below, the Amazon RDS tutorial. Because I'm a storage person, so I didn't develop this myself. So I took an example that is a simple web server running in our compute environment. EC2 is our compute environment, and connected to a database as part of our RDS. That's our relational database service. And this was stood up, and if we go to the next slide, we'll see the sort of simple look of what this is doing. It gives you a table to be able to input names and addresses. The 4 names I added here are the 4 presenters today. The addresses are made up. They're not real. This is not personal information. But the main thing to look at here is the address bar. So you can actually see that I'm connecting to US West 2, which is Oregon. So this is where this is running. Right, in my sort of production environment. So let's go to the next slide. So this is what I've developed, used AWS Backup for to help protect this, is that I have created a backup plan that will back up in my primary location, US West 2, which is Oregon, the EC2 and the RDS database. Now, the EC2 may or may not need to be included because that is stateless. There are ways, Chandra talked about some of the ways to be able to deploy these on an ongoing basis to keep them pristine. But the database is really where the most important data is. That's where normally your application, the crown jewels of your application, is inside of a database. So we're backing this up to a backup vault, which is always going to be local to where the data is in the same region. But then using AWS Backup to replicate that to a second region. And in my example here, I'm going to Virginia, North Virginia, which is US East 1. So the data then gets into that backup vault. We could also go even one step further by integrating with AWS organizations to make that a separate account / region. So even giving us credential difference, air gap between your production and that disaster recovery location. Let's go to the next slide. So let's see this. Now we're looking at the actual protected resources in that DR location. So we can see North Virginia in the top right-hand side. And I've got my EC2 instance. I included that in my backup plan. I've also got my database. So as we would click, if something did happen, I would be able to go click into a resource. So the next slide will show us I'm inside the backup listing of what's inside of my database instance. And I was backing up once an hour and replicating, so you'll see a number of instances here. And I can select any one of them. It does not have to be the most recent. With ransomware, sometimes you don't want to have the most recent backup as your recovery point. So with one selected, you would go hit restore. Restore is an option there just in the middle of the right-hand side, and we'll see next page. You will get options very similar to deploying your RDS database. So here you would better select things like, do you want the same sort of instance class? And next slide, we'll better see other aspects of the selection. If we go to the next slide. The VPC is where you would be deploying this. In my case, I had that pre-built. But again, that could also be orchestrated as part of the disaster recovery, as into the virtual private cloud networking that would be needed for this recovery. Also able to select the availability zone, and then by hitting restore backup, it will go through an extra restore based on those selections. At the end of the restore, you'll be able to see a report on, it started and ran. This ran for about 8 minutes and completed. So that gets us the database into that new region. And if we go to the next slide, we'll actually see the view of the database from our RDS databases and that instance name that is now actually up and running. The CPU and current usage showing that. The main thing to actually extract from here would be the new endpoint name, which we see on the left-hand side, just below halfway, is the endpoint name. So that is going to be unique to this instance in this region. And that's the one part that I would now need to take and either manually or through an orchestration or a script, go place that in the database, so in the web server, because that's how the web server would connect to this database instance by that endpoint name. If we go and click next, this is now the same view, and the only thing difference here is now my host name is showing up that it is out of US East 1. For a real production application, I'm probably putting a more user-friendly, company-friendly, application-friendly DNS name in front of that, maybe managed through Route 53. But I kept these region-specific names in place to show you the before and after, to show that we have now got this up and running in the DR zone, DR region. Next. We are always adding to AWS Backup, released in 2008, and features are being added. This is the most recent one, and something that's actually very near and dear to this conversation is not just the fact that we can do this backup, replicate, and protect, but we also want about a report in this, because you may need to report for compliancy reasons, either internal or external. So this was released just over a month ago for AWS Backup Audit Manager, for being able to report for compliance reasons on your health of your backup and replication status. And the links are here for you to review at when you get the copy of the presentation.